Hello everyone, John here, and after watching the video, my main takeaway is that a step response is one of the most useful way to understand how control system behaves over time. And it shows how the system reacts when the input suddenly changes from one value to another. And from that response, we can evaluate important performance measure, such as rise time, overshoot, and settling time, and the steady state error. And one thing I found very important is that step response is not just used to observe a finished design, but it can also use to set design requirements. For example, if we want a drone altitude controller to respond quickly and not overshoot too much, and we can define those limits directly using step response characteristics. That makes the design goals more practical and easier to understand in the time domain. And the video was very helpful because it also explained that not all step response look the same. Some may look like a normal rising curve, like a high pass filter, and while others can look like a ramp or even a decaying signal like a high pass filter. I mean, the rising curve is the low pass filter. So depending on the system dynamics, that helped me realize that we should not judge a step response only by its shape, but understanding both the input and the nature of the system. And as future engineers, one key insight I gain is that step response is very initiative connection between theory and actual performance. And I also learned that for standard second order system, parameters like natural frequency and damping ratio affect the shape of the response. And overall, this video helped me better understand how engineers use step response in control system analysis and design. That's all. Thank you.